they're the only ones that's completely cartilaginous. All right, and we'll talk more about that in the lecture on a later day. So here we go. As we look at it, let's orientate ourselves too. Here's ventral. Here's dorsal. The eyes would be here. Nostrils would be here. There's the front of the snout, back of the head. Okay, all of that's important as you look at to try to remember things. We're going to start off on the underside. And the first thing we see is this flat area here. This is the basal plate that the brain rests on. Okay? When we talk about development of the Chondrocranium in lecture, you're going to see that two cartilages fuse together to make the basal plate. And when they do that, they surround and engulf the notochord. And I always think this is kind of neat, but you can see right here the notochord. That's what this ridge is. Now, I didn't mention this, but this is a freeze-dried chondrocranium. These are great because you can pick them up easily and manipulate them. Two of them are really good, two of them are not so good, so use your judgment. We also have jars of these, as you can see here. For example, this one, oh, there it is. You look in the orbit, you can see what looks like a little mushroom. This is one of the few ones that show that. It's an optic pedicle. They break off really easily. But you can see these, another nice thing about them, you can even see that here with the light shining down. You can see the light shining through the foramen, which sometimes makes it easy to identify them as well. So you can use both, but remember, sometimes these are leaky. All right, so back to our basal plate. If we move forward, we see a hole here. And that hole is given two names. One name is for the artery that brings blood to the brain coming through that hole called the carotid foramen. The other name for that is for the gland that sits there. The pituitary gland sits there. Now another name for pituitary is hypophysis, so this is called the hypophyseal foramen or fenestra. All right? Now the back of the skull here, we've got a big hole, whereas the brain and spinal cord meet. That's always called foramen magnum, which literally means big hole. Here we see a pair of articulating structures, occipital condyles. This whole thing houses the middle and inner ear. There's no external ear on sharks, but that's called the otic capsule. So if we look at the back, there's a process behind the otic capsule called the post-otic process. All right, this one doesn't show as easily as some of them do, but this whole thing's our post-otic process. We got two portions like bars that are really thick, and then a thinner portion right here. Now that thin portion, and you can see it better on one of these specimens, but I'm not going to be able to tilt it and show it to you without it splashing all over the place. But light will shine through that thin plate of cartilage like shining through a glass on a window. And so that portion of the post-otic process is called post-otic fenestra, fenestra meaning window. What's confusing is next to the post-otic process is a hole. That's a foramen. That foramen is for the glossopharyngeal nerve. So it's the glossopharyngeal foramen, which happens to be cranial nerve number 9. You don't need to remember that. The only reason why I'm telling you that is next to it and behind it, hole for cranial nerve number 10, the vagus. So they're going to go in numerical order, which is the same with all cranial nerves. All right, now we're on top here. And let me get rid of this number 75. We have all these openings, two pairs of openings. The front pair are going to be the endolymphatic foramen, and then we have our perilymphatic foramen. We have a groove going in there, that's the fossa, leading into the endolymphatic and perilymphatic foramen respectively. Here's the roof, the tectum. Here's our eye socket or orbit. The process behind that is the post-orbital process. See how you could confuse post-orbital and post-otic? You got to think about what those names mean. Otic for ear, orbit for eye. And then here, of course, we have processes in front of the eye socket, antorbital process, anterior to. One of the things you'll notice is that right above the orbit, we have this group of holes. These holes are called superficial ophthalmic foramina. Foramina is the plural of foramen. All right, that's a tongue twister. Superficial kind of seems obvious. ophthalmic. Remember, an ophthalmologist is someone who works in your eyes. So these are associated with the eyes. That's where the name comes from. Although in reality they have a different purpose, but we don't need to worry about that. So superficial, to me, they always look like the holes where you tie your shoelaces through when you're lacing up your sneakers. There's a little hole right here in the front. That's the epiphyseal foramen. Okay, another word that will make more sense to you later. But what we see here is an opening for an endocrine organ called the pineal gland or epiphysis. And this gland is the remnants of an eye, believe it or not. And it responds to light stimulation, produce hormones like serotonin and melatonin. Then we got this big thing here, which looks like the bridge of a ship. Think about the old whaling ships. They had that long thing that stuck out from the front that they'd get on to harpoon the whale. That was called the rostrum. And so this is called the rostrum. The cavity in front of the rostrum, pre-cerebral cavity. That kind of makes sense. Flip it over, our rostrum has what looks like a keel on it. And the word for keel is carina. So there's the carina. These structures are always damaged. They should be spherical, kind of like the big ball on Epcot. These are the olfactory capsules. They're very delicate, so they break very easily. The hole leading into the brain from there is how the olfactory nerve gets to the brain, so that's the olfactory foramen. All right, now we're in the orbit. Got a bunch of holes here. The first thing we see is this projection that the eyeball would sit on, infraorbital shelf. A shelf that you rest the eye on, infra, below, which kind of makes sense. It wouldn't work well any other way. This big hole, optic canal for the optic nerve. All right, so we had our superficial ophthalmic coming down. Then we get this one that's right in front of them but does not go to the surface. So that's our deep ophthalmic foramen. This little guy here, going to help to move, this one here is going to help to move the eye in the orbit. That's the trochlear foramen. That's for the trochlear nerve. We're going to see there's a bunch of cranial nerves that move the eyeball, and trochlear is one of them. This little yellowish thing is the optic pedicle broken off. Okay? The only time you're going to see it is when it's not broken, which is very rare because they're extremely fragile. They look like little toadstools, little mushrooms. The big hole behind it is really an easy to identify one. It's called the trigeminal facial foramen. Okay. A big name, a big hole. The reason why it's a big hole is because two cranial nerves go through it, the trigeminal and the facial, which is why they're combined in the name of the foramen here. And then we got a bunch of little holes here. You only need to know one of them. So if I tag anything here that's not trigeminal facial, it's a hole for a nerve that moves the eye called oculomotor. The oculomotor nerve moves the eye, which sounds obvious, right? Now on the side of our otic capsule, back here we have a whole hyomandibular foramen. Now remember we talked about the splanchnocrinium back on Thursday. The hyomandibula, the hyoid apparatus, attaches to the skull, so the jaws are free, they brace against the hyoid. And now we see the exact spot where that happens with the hyomandibular foramen. All right? I don't think I left anything off there. Does anyone have any questions or needs to see something again? Shane? All right, I know, really easy stuff. It comes with time. All right, so get some studying done. If